What's going on, guys? My name is Devante, and today we're going to be going over a few popular methods for data selection in Pandas, namely loc, iloc, and the square bracket indexing operator. So let's jump into it. So let's start by defining some syntax. So here we can see for a series, we have one indexer, which would be the row indexer, because a series is one-dimensional. For data frame, it's similar, but it's two-dimensional. So we have a row indexer and a column indexer. And just to note that loc is purely label based, meaning that integers are valid labels, but they refer to the label and not the position. So I'll show you some examples later on. When slicing, both the start and the stop bound are inclusive if they're present in the index. So let's jump right into it. Let's go through a few examples. So first, we're going to import pandas as PD, which is simply an alias for pandas. I have a dataset called, well, it's a numbers dataset. We're just going to name it numbers. And we're going to read it by doing pd.readcsv. So I'll post this link in the description for you guys. We can see from this numbers dataset that is a data frame. How do we select a single row with loc? Well, we just name the data frame numbers.loc and we put the label. So for example, the index here are all integers, which is valid, but it doesn't go by the position, it goes by a label. So if we output this, we're going to see we get a series. And just to make this very clear, let me make a new data frame called numbers modified. And what we're going to do is just simply set the index to be, let's say, the worded column right here. So there you go. So now we can see it's basically the same, except the worded column is now the index. If I do numbers.loc and I put in the label, let's say 0, you'll get the same result. Let's go into a few more examples. So how would we select a single column with loc? Well, we could do numbers.loc, and we could put the slicing operator, which is denoted by the colon, comma, and then we name our label. So let's say we wanted to do, for example, we want to select the entire positive column here. So we just simply name the positive column, and that gives you the entire positive column here. How do we select a single value? Well, same thing, numbers.loc, and then we can select, for example, the value 0 in the positive column. So you just name the label 0, and then it's in the positive column. So that gives us the scalar value 0. How do we do multiple rows now? It's similar as before. We just do numbers.loc, and you say, what rows do I want? But with the slicing operator. So let's say I want to select all these rows 2 to 5, and they're inclusive. So I just say 2, which is the starting bound, colon, 5, which is the ending bound, and they're both inclusive. So now you can see we have all these rows, 2 to 5. Similarly, we can slice multiple columns with a similar notation. So numbers.loc, and then we put all rows, comma, the amount of columns we want. For example, the negative to the worded column. So we could say negative to the worded column. And here, you can see we have all rows and a negative to the worded column. And we could also explicitly name each column if you want to be more, explicit with it. So we could say, what rows do I want? All of them. What columns do I want? Well, I want all 3 columns. So you put a list, and then you name each of your columns within that list. So I want the negative column, the positive column, and the worded column. And this will give the same result. So a good word to note about the slicing notation here is that the order that the columns appear actually matters when you're slicing. So for example, if I were to put the ordered column before the negative column, such as this, we would only get the indices because we were trying to say that we want to start from the word column and go to the negative column, but there's an implicit step here in the slicing, which is 1. So this is the same thing. This is what it means. So to get around this, what you could do is simply put a step of -1. And what you get is the same output, but the columns will be rearranged differently. Now, let's look at how to mix and match these indexers. So let's say you want to select a subset of the columns in the numbers dataset or any dataset. So you could just mix and match any of these indexers. What I mean by this is you could say, I want all the rows where I want to start from the index 2 to 5, and I want to go from the negative column to the ordered column. So you just do this by either specifying the slice for each row index and the column index, or you can specify explicitly which rows and which columns inside of a list. We get row 2 to 5 inclusive and columns negative to ordered all inclusive. So let's look at how to mix and match the indexers to achieve a certain subset of the data frame. So as before, we name the data frame numbers.loc, and in the square brackets, we can say, I want, for example, rows 2 to 5 and columns negative to the ordered column. And you get this result. So we have rows 2 to 5 inclusive, and we have the columns negative to ordered inclusive. And you could also specify explicitly which rows and which columns inside of a list for each indexer. So for example, we could say, I want explicitly row 2, 3, 4, and 5 within a list. And similarly, I can say I want columns negative, positive, and the ordered column all within a list. And this would give you the same result. So now let's look at how to do some Boolean conditions with loc. So as before, we can name our dataset or data frame, and we could say .loc, and in the square brackets, we're going to say, what rows do we want? Well, let's say we want to select all these rows. So I want all values where the positive column has values greater than 1. So I could say inside the square brackets, numbers.loc, and I want to find the positive column where the values are greater than 1. And you can see we get the same result, except of course I didn't name the listed column here. You can also put the slicing operator for the columns, but it's not necessary because by default, we're indexing the rows. So if we do that, nothing changes, the same result. So how to chain these? Well, chaining Boolean conditions is pretty simple. It's very similar, except we specify each Boolean condition within a separate set of parentheses, like so. So we could say, for example, I want the positive values greater than 1, and we want to split it by some bitwise operator. Let's say the AND operator, which is denoted by the ampersand in Python. And I want to specify my second Boolean condition within their set of parentheses. So we want to say, for example, we want all numbers greater than 1 and less than 5. So we do numbers.loc. I want all rows, and I want to find the positive column again, but I want all values less than 5 and greater than 1. All right, so now let's look at how to use iloc in Python with pandas. So I'm going to use the numbers modified data frame to make it explicitly clear that the index matters by integer position and not by label with iloc. So as you can see, this is what our data frame looks like. And as before, let's say we want to select one row. So we do numbers modified .iloc, and iloc is purely integer based. So that means we want to index by integer only in both the row indexer and the column indexer. And the start bound is included when you're using slicing, and the ending bound is not included. So I'll show you, you'll see what I mean in a second. So to select one row, we can do the 0th index, which means I want to select this row right here, because in Python, all the indexes are 0 based. So let's see what this gives us. And expected, we get a single series right here. Now let's look at how to select a single column with iloc. So as before, we name the data frame numbers mod .iloc. And remember, this is integer based. So we say we want all rows. And which column do we want? Well, I want the listed column, which is 0, 1, 2. That is index. So we say 2. And we get a series with just the listed column. Well, how do we select a single value with iloc? As before, name the data frame, numbers mod, the iloc, and I want to select, for example, -2. So which row index is this found at? 0, 1, 2. And then I want -2, which is in the negative column. So this is the 0th index if you look at the column indexer. Just like so, we get -2. How do we do multiple row indexing or selection with iloc? Well, we name the data frame .iloc, and let's say I want to select rows 2 to 5, and this is by integer position. So we should expect 0, 1, 2, so here, 2, 3, 4, 5. And you'll see that 5 is not inclusive with iloc. So I only have up to row 4. And similarly, if we want to select multiple columns with iloc, we do numbers mod .iloc, and square brackets, we say I want all rows. Which columns do I want? Well, let's say I want the positive column and the listed column. So we can slice it again, and we can say that the positive column is found in index 1 because we have index 0, which is the negative column, index 1, which is the positive column, 2, the listed column. But if we said 2 here, we would only have the positive column because this is not inclusive. So we'd have to say 3. And as expected, we get both columns. So how do we mix and match these? Very similarly, we name our data frame again, .iloc, and we can mix and match the indexers. So we could say I want row 2 to 5, and I want columns 1 to 3. And as you can see, again, we do not have index number 5 that's included, and we don't have index number 3 that's included. We only have index number 2. Now, I'm going to show you guys a few more detailed cases when dealing with slicing and indexing with iloc. So, as you can see here, this indexer for the column indexer 3 doesn't actually exist in our data frame. So we have 3 columns, but they're 0 indexed. So they start by 0. So negative is 0, positive is 1, listed is 2. We don't have a number 3 index, but this is still valid in the slice because in Python, this is regarded as an exception based on the semantics for slicing. But you will get an index error if you specify number 3 or index 3 within a list. So I'll show you what I mean by this. So let's say I want to do the same thing, numbers mod.iloc, and I want rows 2 to 5, and I want to explicitly state that I want 1 on the first column by index 1, 2, and 3. But 3 doesn't exist, so we will get an index error. So I can see index error. Positional indexers are out of bounds. And this is very similar to loc, where well, we had this. And I'll show you. If we do numbers.loc, we can still slice by a non-existent indexer. So let's say we want 0 to index 7, but 7 doesn't exist. We only have 5 rows. It's still okay because this still conforms with the Python and NumPy slicing semantics. However, if we do this, numbers.loc, and we want to specify explicitly in the list, we want rows 1, 2, 3, 4, 5, and 6, and 7. These 2 rows don't actually exist. So if we read this warning, we can see that it says passing list likes to loc or the square bracket indexing operator with any missing label will raise a key error in the future. So for now, this is still supported, but you should still avoid it. And if you need to, for some reason, pass in a missing label, pass it in using the slicing operator, such as right here. Okay, so let's go over how to use the square bracket indexing operator. The square bracket indexing operator is actually called by invoking the getItem method in Pandas. It comes in 2 calling conventions. Either pass in a label for a series, or you can pass in a column name if you have a data frame. So we have a numbers data frame, and let's say we want to only select the worded column here. So it's easy. Let's going numbers, square bracket, and then worded. And you can see we get that entire series. By default, if you're slicing within the square brackets, it's going to slice the rows just purely as convention because it's such a common operation. So if we do, for example, numbers, square brackets, and 2 to 5, it's going to slice the rows. And you can notice that it's inclusive of the first starting bound and exclusive of the ending bound. So if we, for example, take our numbers modified data frame, which has the index set to the worded column, and we want to slice this, you'll notice something a little bit different. So we go numbers mod, square brackets, and if we say I want row 2 to 5, you'll notice that it's actually inclusive on both bounds, unlike if we had integer labels. Okay, so how do we do Boolean conditions with the square bracket indexing operator? Well, it's similar to loc, but we don't need loc. We just do, for example, numbers, square brackets, And let's say we want to select all values where the positive column are greater than 1. So you can just name it numbers dot positive greater than 1, and there you go. So now let's go over how to use two a little less commonly used calling conventions with loc, iloc, and the square bracket index operator. So these two calling conventions are by Boolean array and by callable. So first, by Boolean array, we have our data frame numbers. And let's say we want to select rows 2, 3, and 5, for example. So how do we do this? We say numbers.loc, square brackets, and what rows do I want? Well, I want to pass a list because I want to explicitly name a Boolean array. I want to exclude the first two rows, so with index 0 and 1, so I say they're false. I want row 2. I want row 3, so I say they're both true. I don't want 4, so I say it's false. And I want 5, so I say it's true. And there you go. You get rows 2, 3, and 5. And now, to pass in a callable, which is basically a function with one argument, we can do numbers.loc or numbers.iloc or with the square brackets, doesn't matter. And we can pass in, let's say, I want to say all rows, but the columns I want are the positive and worded column. Well, if you have a user-defined function, you can pass in here, or if you make a anonymous function, such as a lambda function, you can pass it. So since I'm going to be getting a data frame back, because I have two columns, I'm just going to say df, and this is our argument here. And our expression for our lambda function is a list. So I want the positive column, and I want the worded column. And what it's going to do is pass this list for each row into the column indexer. And that's why we get all rows, and we get only the positive and the worded column. All right, guys, that's all I have for today. Thank you for watching the video. If you guys liked it, please leave a like. If you didn't, leave a dislike. And be sure to subscribe if you want to see more programming tutorials. That was all. I'm out. Take care.